Okay. Bismillahirrahmanirrahim. So today our lecture is about ratio control. Okay. Ratio control is a mechanism, or this is some kind of addition to the feedback control. जो normally हमने study किया है उसमें we before we have studied के set point है. This goes to a controller. For example, last time we studied about the PI controller. Okay. And then we have PI controller may be running some kind of a valve, और वो valve जो है किसी process के अंदर changes करेगा. We will have some output Y. Y will be measured and sent back to here, minus and plus. So this is our simple feedback control. Okay. Now in process industry, we need some more or advanced controls. So उसमें सबसे पहला जो control है जिसको हमें पढ़ना चाहिए, that will be ratio control. ठीक है. So ratio control, अब आज हम देखते हैं कि what is basically a ratio control. ठीक है. So this is a little bit different from the feedback control, right? अच्छा, ratio control में हमारे पास अच्छा back end पे इसके ज़हन में रखिएगा कि what we have here is, in this system we have a disturbance, and feedback control we are not taking care about. Our controller has no idea about the disturbance. So in feedback control, controller has no idea about the disturbance. D. Okay. So in feedback control, the controller has no idea about the disturbance. This ratio control में क्या है? If we see, it's very interesting. यहाँ पर अगर आप देखें तो आपको how many measurements do you see? What I see is we have a measurement of flow transmitter here. ठीक है. Disturbance stream चलती जा रही है. So we have a flow transmitter here at disturbance. I'm talking about, अच्छा चूंकि ये ratio control is all about the controller itself. तो हम controller perspective में, so we so think about it कि just we are think from controller perspective. ठीक है. तो पहले तो हमारे पास यहाँ error था सिर्फ, but this time in ratio control we are not focusing on the error. Ratio control में हम ratio control करेंगे. So we have one measurement from the flow disturbance as a flow transmitter, और इसको हम कहते हैं, let's say if the measurement is coming from the disturbance, so हम इसको कहते हैं कि the DM. So DM is the disturbance measure. Disturbance underscore measured. Okay. Now coming to the main system जो है वो आपका ये है पूरा process. ठीक है. उस पूरा process के अंदर, now here we have the process going on. इस process के अंदर we have the manipulated variable here. Okay, this is just like MB. And the manipulated stream जिसको हम change कर रहे हैं, main कर रहे हैं, we also have a flow transmitter from here, U. So this is measurement for the U signal. ये दोनों यहाँ पर आते हैं, and then we are dividing it. तो dividing का मतलब है कि we are generating something like this, dm upon dum, a sort of a ratio. सो हम यहाँ पे क्या कैलकुलेट करते हैं, हम वी आर मेकिंग सम इन रेशियो कंट्रोल. व्हाट वी डू इज नंबर 1, वी measure two variables. Then second step is we calculate ratio, and this ratio is provided to and give it to ratio controller. अच्छा, यहाँ इंटरेस्टिंग चीज ये है कि हम जो कंट्रोलर को अब दे रहे हैं, वी आर प्रोवाइडिंग इट RM. फीडबैक कंट्रोल में हम उसको प्रोवाइड कर रहे थे E, एरर. इस दफा हम इस कंट्रोलर को प्रोवाइड कर रहे हैं RM, एंड दैट्स व्हाई इट इज कॉल्ड रेशियो कंट्रोलर, राइट? Another thing that we can see here is since the controller is a ratio controller, तो इसका जो सेट पॉइंट है, वो सेट पॉइंट भी आपके पास एक रेशियो होगा. So what we are providing here is we are providing a set point of the ratio, और ये सेट पॉइंट जो आप कंट्रोलर को दे रहे हैं, एंड वी आर प्रोवाइडिंग मेजर्ड रेशियो टू द कंट्रोलर. Ratio to controller, and then controller is generating a control signal here. Control signal. ठीक है, ये स्लाइड पे बात समझ में आ रही है. We are actually gradually shifting from simple feedback control से अब हम मूव कर रहे हैं towards feed forward control, जिसमें रेशियो कंट्रोल इज बेसिकली अ फीड फॉरवर्ड कंट्रोल. इट्स अ रेशियो कंट्रोल. ठीक है, तो जहां पे हम बात करते थे एरर की, अब वहां हम बात कर रहे हैं रेशियो की. ठीक है, ये स्लाइड क्लियर है सबको? इसमें से कोई सवाल? ओके, सो व्हाट्स हैपनिंग हियर? By the way, in ratio control, what we have seen here is one type or the method 1 to implement the ratio control method. ठीक है, इसकी एक और implementation भी है which is called method number 2. Method 2 में क्या है? Again, we will be measuring the disturbance with a one flow transmitter, and we will have a variable DM. On the other side, हम जो मेन स्ट्रीम है उससे U वेरिएबल कंट्रोल कैलकुलेट कर रहे होंगे, मेजर कर रहे होंगे. We will have UM, but this time this UM is not used to calculate the ratio. Rather than हम इस रेशियो को इनकॉर्पोरेट कर लेंगे इस इक्वेशन के अंदर. ठीक है, इस इक्वेशन के अंदर, रेशियो स्टेशन के अंदर. Here we are calling it ratio controller. Here we are calling ratio station. Ratio station means the DM disturbance will reach to the ratio station, and ratio station is just like a small microcontroller, will calculate a new value of set point for U based on measured disturbance. ठीक है, प्रीवियसली जो मेथड नंबर 1 है, अगर हम उसको यहाँ पे ड्रॉ करें, मेथड 1 में क्या था? मेथड 1 में हमारे पास इसी तरीके से एक फ्लो ट्रांसमीटर है, and this is providing DM here. We have a flow transmitter from here which is providing a UM. ठीक है, ये दोनों जाएंगे and they will go to our divider. डिवीजन होगी, इस डिवीजन की बेसिस पे आपके पास RM जनरेट होगा जो कि मेजर्ड ratio है. This is the measured ratio or ratio of the measured quantities. I will call measured ratio right now. ये आप प्रोवाइड करेंगे अपने कंट्रोलर को जो कि रेशो RC है, रेशो कंट्रोलर है. सिंस दिस इज अ रेशो कंट्रोलर तो हम इसको जो सेट पॉइंट देंगे वो भी रेशो का होगा. सो R we will call it RSP, set point of the ratio, and then this will generate a control signal directly to the control valve which is installed here. ठीक है. Or this will be our let's say P signal. ठीक है. This will be the control signal. So the difference between method 1 and method 2 of ratio controller. Is it clear to all? इसमें कोई सवाल? आगे जाके हम इसकी मज़ीद डिस्कशन करेंगे, बट ऑन दिस स्पॉट कैन यू फिगर इट आउट? अच्छा, इसके करिस्पॉन्डिंगली हम अगर फीडबैक कंट्रोल सिग्नल बनाएंगे तो दैट कैन बी एन इंटरेस्टिंग थिंग. Okay, but before that, I would like to stay here for a minute and ask you a few questions. Do you understand what I have presented to you? Any questions till now? Ji, anyone? No questions so far? So my question can be now. I would like to put one question, or you can expect this in the quiz. For example, draw the feedback control loop here. Okay, so अगर मैं एक फीडबैक कंट्रोल लूप यहाँ पे बनाना चाहूँगा तो कैसे बनाऊँ? How? In the feedback control loop, I would like to know कि what is, let's say, flow transmitter क्या है? This will directly go to a flow controller, and I will provide, let's say, if this is, let's say this is U of M, then we will provide U of set point, and this will generate a control signal. और ये कंट्रोल सिग्नल एक कंट्रोल वाल्व को कंट्रोल करेंगे. Now what is missing here? What is missing or different here? Anyone, please? This is the feedback control. इसमें क्या चीज मिसिंग है और कम है? जी, anyone? Okay, so get ready for a pop-up quiz for tomorrow from this chapter. तो ये सवाल हैं, इनके हिसाब से हम इंशाल्लाह कल दोबारा I will ask you these questions. Okay, now this is a ratio scheme, for example, in for ammonia synthesis reactor. Since we are talking about the control aspect, so we will ignore other things and we will focus on these two things. कि रेशियो कंट्रोल में जो हमें चीज चाहिए, इन रेशियो कंट्रोल or controller, we need to measure two things, two important variables, right? Number one variable will be, the first variable that we need to measure is the MV, manipulated variable, जिसको हम U कहते हैं, and the second thing is the DV, which is called the disturbance D, right? So if we have we are actually controlling something, we are manipulating, this is something, this stream is being manipulated, so this is a manipulating stream, और इसको हम खुद ही manipulate कर रहे हैं. So this is the control signal, this whole control signal is generated by us, ठीक है, जो implement हो रहा है. And this is being, so if we are actually controlling till here, okay, we are actually controlling this thing, maybe this may be open 20 or 30% or whatever the signal is, and the stream is going through this one, okay, and we are measuring this stream कि इसमें कितना change आ रहा है. So this UM will go to a flow controller, it's coming here. And similarly, we have some kind of a disturbance, H2. Why we are calling it disturbance? Because this will vary. This will change by itself. Okay. And we have a small local loop or controller is also here. And but we also have a measurement here, TM. So this will go to a ratio controller. Our ratio controller में क्या था कि ratio controller is the thing that will accept at input the disturbance, measurement disturbance, and it will generate the set point for the MV. Okay, so set point generator, and so this combination is this is a sort of a feed forward controller or the ratio controller. Okay. Next. So basically what's happening here, by examples we have seen कि अगर हम किसी प्रोसेस की बात करें तो उस प्रोसेस में एक वेरिएबल होता है जिसको हम कंट्रोल करते हैं. We usually call it Y or the control variable. And basically behind that process we are manipulating few things. For example, we might have access to a pipeline like this one कि जिसको हम change कर सकते हैं. So we have access to the changing of this. So this is called the manipulated variable, and then we have the disturbance variable. So we have three things, D, U, and Y. And control objective is what? We have to maintain the Y at its set point, some Y of SP, despite the disturbances. So this may be constant and may start changing, okay? So even if it is making some changes, what we want is कि ये जो y है ये अपनी सेट पॉइंट पे y ऑफ सेट पॉइंट अगर फॉर एग्जांपल ये है तो आपके पास ये विद स्मॉल वेरिएशंस ये यहीं पे रहना चाहिए. ठीक है जी. आई हैव अ क्वेश्चन राइट नाउ. ओके, नो प्रॉब्लम. So focus here. So the feedback control. Okay, so quiz will be, don't worry about it. I will give you some homework rather than that. So the feedback control. So this is the control objective, right? Okay, no problem. Then we talk about the feedback control. Now in feedback control, हम क्या करेंगे? In feedback control, we will be measuring this Y. We will be comparing it. We will take this one and we will compare it with some kind of a y set point, okay, plus minus, and an error will be generated. So adjust, and then we give this error to our controller, and that controller will take care about this generating a new U, so that if there is some variation here, and let's say the variation, the value is 10 here, and the variation, new variation is, let's say, 15. So it will generate an error of 5, and according to error of 5, it will generate a new value for U, so that it will come back to 10. So measure Y, compare it to Y of set point, adjust U so as to maintain Y at Y set point. So this is called feedback control. Okay, ये हम पढ़ते हैं. Widely we use PID, and last lectures we focus on developing the BI controller. And this is a very basic or fundamental concept, right? Okay. So what about the second one, the feed forward control? Now in the feed forward control, here we have to measure D and we adjust U so that we maintain Y at YSP. So note that the control variable is not measured. Now this time it's very interesting. We are not measuring the Y. Instead, we will measure this value here. Okay, so this is so feed forward and feedback control. This is a comparison. This is a feed forward controller. Here you will not see any measurement. So here what you are measuring is what? Only D. And the control signal, control output is U. In this case, second case, your measurement is your Y, and the control output is still U. So this is called the feedback or feed forward controller. First one is the feed forward. Okay, and the second one is the feed back controller. Okay, now practically feed forward control is good in rejecting D. Feedback control is good in any issues with the let me write it down. Feedback control good against usually any issues with the process model, with the process. For example, we are talking about the process model. Maybe the process is not very accurate. We may have some measurement issues, okay, model uncertainties. But while feed forward control is very good against disturbances. By the way, now there is a question I would like to put here. That may compare the Y feed forward performs better in rejecting or dealing with disturbance as compared to feedback control. Okay, so keep in mind to figure out the answer to this question. ठीक है, why, क्यों हमारा feed forward controller जो है वो disturbance को बेहतर अंदाज से रिजेक्ट कर सकता है एज कम्पेयर टू द फीडबैक कंट्रोलर. आई विल रिपीट why and how feed forward control behaves better in dealing with the disturbance as compared to the feedback control. Okay, now continued with few more examples. This is an example of this is liquid level in a boiler, or we have a feedback control here, simple feedback control. We are measuring the level here, and then this level goes to the controller, and controller is manipulating the feed forward. Water is manipulated by changing the value of the valve. Okay. Now this is example of the feed forward control of the same boiler drum level. This time we are actually calculating the disturbance. Okay, this disturbance goes to the feed forward controller, and it is manipulating the feed water. Now the combination of these two will be interesting, feed forward and feedback. We will continue from here tomorrow कि ये दोनों combine करते हैं तो किस तरह से ये काम करते हैं, ठीक है. But a little definition here. We have the disturbance coming from here, we have the measurement coming from here, the level, and these both. So this is a feedback control, we have a feed forward control, and these are both are used to manipulate the feed water. Okay. Okay, any questions till now? We will continue from here. I will upload this slide और इसको पढ़ लीजिएगा so that tomorrow we will go quickly. Right? Any questions till now? Okay, let me take the attendance now.